And we're live, folks. Hello. Thank you for joining us. My name is Nicholas Lane. It's great to be hosting Flower Monthly for June. I've joined here with three exciting guests that I'll introduce shortly. Um, but we're going to get things underway. Um, so the agenda is for June, we have a quick 5-minute series of updates about flower, what's happened in the flower community and the ecosystem in the last month since we had Flower Monthly before. And then we have these three exciting talks that I alluded to before. We're going to kick things off with Chong Shen. He's part of the Flower family, part of Flower Labs. You would have seen him a number of times. He's going to give us a talk about using flower in production. We had a lot of requests for a short talk of this nature, so I'm really excited to have him come along and deliver that. Um, then we have Andre from Vector Institute. He's been building this amazing new framework called FedRAG that's built on Flower and enables you both in centralized and in federated settings to do things like fine tuning and RAG and all these great things that are so powerful. And then we're going to end the show, end the monthly with Adipata. She's from the Heilbronn University, and she's going to be telling us all about work she's been doing in the area of decentralized trust. So, in one show, we're going to cover sort of like the full gamut of things that are federated. Um, Before we kick things off and I hand over to Chongshen, I'm very briefly going to tell you about a few flower updates. I just cherry picked a few things out there. There's so many things going on, I couldn't tell you about all of them. And so, first thing was a big thank you to so many of the contributors out there that went sort of far beyond the call of duty in doing things for and with the community and contributing. And as an example, many of you promoted the Flower AI Summit that was a couple of months ago extensively within your own network. It led to it being the largest by an order of magnitude than most events of its kind. And we had a great time in London. And so some of you have been sending in photos of some of the swag we sent out to people really going beyond the call of duty. I want to share it with you all so you can check out, um, yeah, some of these gifts. Um, I also want to highlight that we are hiring in the go-to-market area. We announced this position in the last few weeks. It's incredibly important for us to be able to get the mission even further out there and adopted, not only by research and not only by open source community, but by also enterprise folks too. And so this is a key part to making everything fly. And so if you know people out there who are interested in doing work of this kind, I would like to hear from them. You can see the full description out there in the careers site. Um, as usual, it's been a busy month also for outreach beyond just Flower Monthly. Big shout out to Mohammed, Demetrius, and William, who ran a really fantastic tutorial that was based in Tampa, if I'm not mistaken, at least in the Florida area, on federated learning. I myself was in Boston visiting a number of users and organizations who are big Flower supporters and users out there. That was a fantastic visit. And you also see here, William attended quite a big event to do with decentralized methods based in New York, and he was pitching the collective one model we're training with Varna. That actually I've seen a lot of outcomes just this week from Jan at the Flower team, who's really working hard on this. Um, Finally, not only do we build a great framework and work with open source and sort of work with you in building these tools, for us to succeed, we're going to have to solve a number of hard, tough problems that are in the R&D variety. And so we thought we'd gather all the different work that Flower is doing in that dimension as well and put it under one roof. You can find all these pieces of work ranging from, optimizers, data set work, um, work to do with like the Flower LLM leaderboard. You can see all of this work now in one place, and we call it flower.ai/research to find all this work. I want to highlight that as well for you. And that is the sort of quick whistle-stop tour of what's been happening with Flower this month. With that, I am going to hand straight over to Chong Shen. He's got a talk for us today. He's titled Productionizing with Flower. I'm super excited to check it out. And so over to Chong Shen.
All right, thanks, Nick, for the handover. Thanks for the introduction as well. Hi everyone. Hopefully you can see my screen. If not, just give me a shout out. So yes, super happy and super excited to be here. My name is Chong Shen. I'm a research engineer at Flower Labs, one of the core contributors to the framework as well. And I want to tell you today, just walk you through very quickly about the features that we have right now in Flower in the latest versions, and how you can productionize your FL workflows with Flower. So let's get started. Now, we want to move from prototype to production. So what we typically do, or a lot of times that we do, is we could start with notebooks, and then we move to scripts, and then we try to orchestrate them with some containerizations to get everything working. So working with notebooks is perfectly fine, but sometimes it's quick for rapid iterations. You want to test something out quick and dirty, but there's a problem, right? And the reason is that notebooks don't automate, you don't deploy, and they don't scale very well. So one of the memes I like to put out here is that if you try to run an FL in a notebook, 10 clients, no logging, no versioning, no restart logic, it's a recipe for disaster in the long run. So really, your notebook can't deploy this kind of complex or this kind of workflows that you need to suit your problems. So one solution to this is the Flower CLI. And this is your first step to use Flower to scale your FL workloads in production. So right now, in Flower CLI, we have 5 core Flower CLI tools that starts with Flower New, Run, Log, LS or List, and Stop. And all of these are very friendly to use. The first tool here, which is the Flower New, quickly helps you build templates from scratch. So it reduces a lot of boilerplate code, and it reduces your time to iterate on your code itself. And with the other 4 commands of run, log, ls, and stop, you can use the same set of commands that you use for research and as well as production, right? Because using the Flower CLI, you can directly interact and send instructions to your applications and use the same commands also in production. What this means is that you can very seamlessly move between your research or your simulation environment and deploy the same code and use the same exact commands. So all of these you can look up right now in our documentation at flower.ai/framework, and the key there is ref API CLI. So with the CLI, you have the first step to really scale out your workloads. So now we look at the Flower components. The Flower components right now that we have are production ready. And what do we mean by that is that we offer now the official Docker images. We have done that for a couple of releases. You can get them at hub.docker.com/u/flwr. What these images have is it provides you a very flexible and optimized way to deploy images depending on your workloads. So for example, for the base images, you can choose either the Ubuntu or the Alpine images. Alpine are the very hyper slim images that you can really lock down and make everything concrete, so you don't inject any unnecessary dependencies for your applications. The Python versions also now span from 3.9 to 3.12, and in fact, 3.12 is something we just recently introduced, maybe not more than a month ago. So yeah, we're pretty happy to see support for new versions of Python there as well. And of course, for operating systems, we have to support for the AMD 64 and ARM 64 type of operating systems. So all of these give you flexible ways of deploying your workloads in production. Now, talking about deploying workloads in production, let's look at how you can very quickly distribute Flower on systems. So here I'm showing a vanilla architecture of Flower, where it has 3 main components. You have the server, and then 2 clients. This is a very prototypical architecture of a hub and spoke model for FL. And here at the top, you can see that the Flower CLI interacts directly with the server. So let's break it down a little bit more. Within the server, you have this long-running component called the superlink. We have the Docker containers for that. And also we have the supernodes that run respectively for each of the clients. Now, these are the long-running infrastructure services that you don't really have to worry about, but that's there and ready to receive any commands from the Flower CLI, and also to execute any of the applications on the server or the client. So for that point, You then have these server apps that talk and communicate directly with the Superlink, as well as the client apps that communicate directly with Supernodes. The gist of this is this. With this simple architecture, which we run in a so-called sub-process mode, you can deploy them in 3 steps. The first step that you do is to install Flower on the user's machine. So with the pip install flwr. Next, you start the Superlink container with the Docker run flower/superlink. And there are some additional arguments to configure your pods, certificate deployments, etc. So just for completeness. And then finally, you start the Supernode containers, as many as you need in your distributed system. And that's it. So with these 3 steps, you can get a fully working Flower in a distributed systems. You can deploy them on physical devices or in the cloud. Talking about containerized deployments, you can find them all in our framework docs at deploy.html. You can also manage and orchestrate these Flower containers, beyond just doing a Docker run. You can orchestrate them using Docker Compose, Kubernetes, and also Helm charts. And we have the documentation that can help you get ready as well for that. How about authentication? So this comes in the aspect of secure usage of Flower. For authentication, we have pre-existing node authentication. So what this means is that you have the supernodes that connect to the superlink, and it's using a signature-based authentication over TLS connections. This ensures that the supernodes that connect to the superlink are the correct supernodes, and you don't introduce any malicious actors that can participate in the federation itself. Moving from the authentication of the components to the user authentication. Yes, right now we also have the features that enable you to spin up user authentication for your Flower federations. So what this means is that with the command flower login, flwr login, you're able to enforce authentication to a certain set of users, and only these users can securely connect to the Superlink using the OpenID Connect protocol. So this really locks down the usage of the Flower federations and ensures that you have full control over your identity access management process. From the aspect of traceability and transparency, we also have event logging features within the Superlink. So what this means is that you can enable a flag in a Superlink that tracks all the user events and application events for each of the actions. So in this case, when it's enabled, you can capture the timestamp of the event, the actor that executes the specific event, the description of the event itself, and also whether the status was successful or failure. So all of these are very useful, especially for auditability and to ensure and for the administrators of the Superlink as well as Supernodes to determine who is running what and when. So summarize, if you're ready for production, so is Flower. And with that, I just want to leave you at the summarization page here. We are ready for scale for Flower components. We have the Flower CLIs that can help you quickly build and use Flower in production. You can also have user authentication to securely connect and execute your Flower workloads. All your nodes are authenticated with the Superlink, and you can also enable traceability and event logging. Yeah, so that's it from my side. I don't know if we have time to. I can field some questions, or if you want to ask me any questions, feel free to ping me on Slack as well. I'll be more than happy to answer them there.
Yeah, we have time for a couple of quick questions if they're out there. So if anyone's on the live Zoom, feel free to raise your hand. I'll unmute you. I'm also consulting the YouTube and the Slack, so I'll look for any questions out there. Yeah, anyone want to jump in there? Looking, well, we just had this isn't a question, just a comment from one of our users saying they're a long time Flower user and they love it. That's great to hear. I guess it's not a question. Not a question. I guess I'll ask a question, and that would be, when do you see people going from, have you seen people adopting our Docker images as we started to release them quite a lot? Or what scenarios do you find that people are using the Docker images most for?
Yeah, that's a good question. A lot of these cases come from users who want to run their workloads on physical machines. So we've seen I've seen two broad classes of users. One who wants to run an experiment on just in devices. They don't want to worry about um, installing all the dependencies, and they can just spin up very easily, and that helps them get it up and running very quickly across all their physical devices. And then there's a cluster of users who also want to deploy them within their own self-hosted infrastructure. And for that, by default they will use containers that makes it so easy for them to spin it up on any of the cloud infrastructure that they want to host Superlink and Supernodes. And the compute can also be isolated in different virtual machines. So yeah, quite a variety of uses right now.
I see. Makes sense. Yeah, cool. Oh, I see Andre wants to ask a question. So yeah, Andre.
Thanks, Chong Chen. Quick question on, I think you shared three quick steps, which I think is great to get this up and running. I think that stands up or spins up the infrastructure needed to do a whole federated learning task, right?
Mhm.
The only thing I think was missing, but I believe it's probably in your docs, is the actual app logic that you would need it. So if you go back to your three steps, I think you're just like running two Docker images, but where is the like the training task actually contained, if that makes sense?
Yeah, it's actually shipped within the client app itself. So if you spin up
I see.
the Flower supernode um, with the in what we call the sub-process mode, the supernode container itself will spin a sub-process within this container environment, and that will execute the application. So, for example, if you have some form of PyTorch workload, you know all the dependencies, you can then build your own supernode image that contains all these dependencies for the client app to run. Then you only need to spin up one single container that has a supernode, which is able to spin up its own client app within its own container.
Okay, so you bundle the app within the Supernode, and I
Yeah,
guess that's detailed in the docs that you guys have
yeah,
prepared.
correct. This is a
Okay.
vanilla way of doing it. There's also a
Okay.
possibility of decoupling it. So um, if you do it the approach that I described, where you have the supernode that spins the client app in a sub process, the dependencies of the image become quite big, and you have to handle these kind of large dependencies. What you could do instead is to deploy them in what we call the process mode. So the supernode becomes a very slim image that simply receives instructions from the superlink and then conveys these instructions to the client app. Now, what you do instead, you spin up additional what we call the Flower client app processor or the Flower client app containers. So this sits in addition to the supernodes, and it will wait for instructions from the supernode in order to run any workloads. In this way, there's also a benefit because you can truly isolate the dependencies between each of the applications and really harden the containers that run the supernode workloads.
Cool. That sounds awesome. I delve into it a bit further, but sounds great. Thank you.
You're welcome.
Cool. Well, then that was a great point, I think, to transition. And so let me just quickly share my screen again because our next speaker is Andre. Andre asked this great question. So it's appropriate that we hand over to Andre here. By way of introduction, Andre is working at the Vector Institute. I actually had a chance to chat to him earlier this week and learn all about his interesting path in the previously, he's worked at, for example, Llama Index, if I remember correctly. He's
Hmm.
also done a PhD in sort of statistical areas. And he's passionate about, I think, bringing federated methods to the fore. And to do that, he's created a really wonderful library that is accessible to people who are really into, conventional centralized regimes. He wants to make it easy for them to do this fantastic stuff in the direction of RAG and all these interesting use cases, but also kind of find a way to make it dead simple for people of in that sort of community to then transition to federated, which is something obviously we're really passionate about here at Flower as well. So it was great that he had time to drop by, tell us all about this amazing framework he's built that uses Flower, but also uses a lot of the other tooling out there that's really, important for the other parts of the puzzle when you're doing these sort of things. So yeah, on over to Andre. I'm really stoked to hear about FedRag and everything you've been up to.
Cool. Awesome. Thanks so much, Nick, for that introduction. Can you all see my screen?
It looks good.
Perfect. And yes, so Nick, you did a great job in introing like the genesis of FedRag. I don't know if I had to touch on it a bit further, but yeah, so essentially, FedRag came about when I was at Llama Index. I noticed some demand for RAG fine-tuning, and some of the closed source LLM providers offer fine-tuning APIs, but they're a bit restrictive in the sense of what you can sort of do. Obviously, with like white box model, excuse me, access, you can fully leverage the fine-tuning capabilities. And so, the user demand for RAG fine-tuning existed, and I realized that at my time at Llama Index. And then with this whole decentralized, like, and definitely Flower has been pushing this for years now, right? But with the emergence of like MCP, so Anthropic's Model Context Protocol and Google's Agent-to-Agent protocol, it just seems that like, those are both inference type of decentralized settings that perhaps federated learning is going to increase in terms of relevancy in the coming years. So we've made this framework, FedRAG, as a simple way to facilitate RAG fine-tuning across both centralized and federated architectures. And Nick was definitely right. One of my passion areas here is to make it like almost for free when a developer builds a centralized RAG fine-tuning task, that they have the federated capabilities via like a one-click type of access. And we'll see that in the slides and hopefully in the demo as well. Okay. Okay, so maybe I kind of touched on this already, but the philosophy of FedRAG is to make state-of-the-art RAG fine-tuning methods accessible to all of our users, and our users will be, I imagine, folks who are building these things for their companies and their either organizations and their business needs, as well as researchers who are, pushing the frontier forward on fine-tuning and RAG fine-tuning in federated settings as well as centralized settings. So making it super easy to access these methods and create new methods is what FedRAG is all about. And our design principles in order to achieve that for now, and these, I should mention that FedRAG, the first commit, I think was January 15th of this year. So we're super early, 5 months into it, but these more or less have been our design principles that have been anchoring us. So advanced RAG fine-tuning, very in line with the philosophy, support state-of-the-art RAG fine-tuning, be up to date on modern techniques and onboard these techniques as much as possible. Also supply, not yet, but hopefully in the future, easy ways to customize or bring in your own trainers so that you could do more research. The second design principle is work with your tools. And this one is something I noticed within my time at Llama Index is that the ecosystem that you know those players are a part of, they're very collaborative and lift each other up. And I think it's beneficial to sort of get in those collaborations just to you know use up or sorry uh, use one another's energy and sort of in a synergistically way, I think, if that's a word. The other thing is that our users have their tools and their workflows, and we don't want to perturb that as much, right? We want them to use their own scripts that they're comfortable with in building with Unsloth or Hugging Face, and then let our framework do the job of federating those. And then the other thing is lightweight abstraction. So we don't want the developers to get bogged down on these complex implementations, right? Or like a lot of indirection within the framework. It makes it very difficult to understand what's going on or how to extend it. And so we're really trying to build FedRAG in a way that is, lowering the learning curve. So again, allows the developers and the researchers to really focus in on the innovative challenges to move this field forward. And hopefully that comes through as you sort of see the demo as well as the quick starts that I will go through. Okay, and these are just some visuals I just sort of created and I've been sharing on my social as we sort of build these things up. But FedRAG, when it was introduced, we said there were a few integrations. There was Hugging Face. By the way, it's PyTorch native. We have this Llama Index bridge to it. You can use Qdrant as your knowledge store. For folks who are not yet familiar with RAG, I should probably take a step back and say RAG is a system comprised of essentially three parts. You've got your retriever model, you've got a generator model, and a knowledge store. And what happens is a user query comes in, it gets encoded by the retriever. The knowledge store retrieves the relevant knowledge facts stored within it, and then those knowledge chunks, as well as the user query, are passed to the generator in order to produce a response. And you use RAG essentially to provide more accurate responses because LLM generators, their knowledge obviously is contained in the parameter weights, and they also might not be trained on most recent data. So um, that's the reason why you would use RAG. Why would you use fine-tuning of RAG? There has been research that showed that optimizing these three components so that they work better or work in concert with one another actually leads to better performance of the system. And so that's why you'd want to fine tune. And then I already mentioned the decentralized aspect that with MCP and A2A taking off, that there's probably, my bet is that Federation's probably going to take off in this space too. We've got, since, we released in mid-May, we've added integrations to Unsloth. So you can, use their accelerators and their models that they've done a heck of a job. I think they've just mentioned in their LinkedIn that they've got 100 or more notebooks now that they've patched a bunch of these pre-trained models and PEFT models in Hugging Face, and you can get like 2x speed up in terms of fine tuning with using Unsloth. And so you can bring in any Unsloth model as your generator and build a RAG system as such. The Llama Index and LangChain integrations are essentially, I think they're mostly used for testing, right, or quick prototyping. The way I view LangChain and Llama Index is that they probably offer a little bit of fine tuning through whatever OpenAI and Mistral AI expose. But I view them mostly as inference frameworks for RAG. And again, FedRAG is a fine-tuning framework. So the idea is if you've finished fine-tuning and you're happy with the performance, maybe you want to or have processes built on LangChain or Llama Index, and you want to use those fine-tuned models quickly to see how they would work within the rest of your downstream processes. So we've built in bridges to Llama Index and LangChain. So you could do something like RAG system to LangChain, and what you get in return are LangChain native objects, or to Llama Index, you'll get a native Llama Index object, and then you can sort of run with it within their ecosystem. And then the final thing here is we just added this no encode RAG. I made up this term. Hopefully, no one gets mad at me. But essentially, you get rid of the retrieval here, retriever encoding. Uh, with MCP, what happens is now these LLMs or systems can access third-party tools or data. So the way that we view it for FedRAG is you can build a knowledge store that is connected to a bunch of MCP knowledge sources, and you can query them using natural language. And as you are building or bringing in third-party knowledge sources to your RAG system, I think it actually becomes a little bit more relevant now that you want to fine-tune on these third-party sources because your generator probably has not seen that data. And so adapting it to that knowledge source could lead to better optimization. But yeah, this just shows you again, like we're trying to build FedRAG in a way that's deeply embedded with the ecosystem to allow users to work with their tools, hopefully, and it's not really seen here, but like lower the learning curve. And, when research actually, if a researcher has a new training objective or FL technique that they want to implement and they add it into this library, then, being deeply embedded in the ecosystem makes it, I think, easier for all these folks who are building with these tools to access that stuff. So further reach and dissemination for research in our view. Um, and I will go into a demo and short overview of some of the quick start so you get a handle of what the API looks like for FedRAG. But yeah, just wanted to mention contributions are definitely welcome. So if you feel like contributing to open source and like RAG and like federated learning, then please do consider contributing to FedRAG and starting us on GitHub. This is definitely an important piece for us as Vector. We and most I think institutions look at stars and engagement through GitHub as a signal of the project having some interest from the community, and that interest is what we ultimately use to resource against our project. So if you like us, please do support us. Okay. And then how much for time, Nick? About 5 minutes or so, or
Yeah, you can go a little bit longer for a demo, I think, because the people really engage with those.
okay, cool. So just wanted to show real quick before the demo, just 2 minutes, the docs that we've got set up. So this was just the philosophy and our design principles. But if you go into our getting started and you hit our quick starts, there's a few here. And I'll definitely talk about the centralized to federated, because we said on the onset here of trying to make going from centralized to federated learning as seamless and as painless as possible after you've done the brunt work of setting up a centralized training task. And I'll get into that last, I think, and I'll just show real quick on these, like the interface. So, uh, right, so you've got a RAG which is comprised of a knowledge store, retriever, and generator, and you install FedRAG with pip install FedRAG. But essentially, our import patterns are such that you can import from FedRAG retrievers. You don't even need to go into Hugging Face like that. We've made this a lot simpler. So it's like from FedRAG.retrievers, import Hugging Face sentence transformer retriever. So that enables you to use any sentence transformer that you want that's available in Hugging Face as your retriever. For knowledge stores, we offer three things. We offer an in-memory knowledge store. So from FedRAG knowledge stores in memory. Again, you don't need this in memory. You could just use .knowledge stores. You can load the in-memory knowledge store. We also offer a Qgent one, and we also offer the no-encode MCP knowledge store as well. And then similarly for generators, we have the Unsloth, Hugging Face PEFT model, or Hugging Face pre-trained model. So that again means you can use any models available on Hugging Face as well as Unsloth as part of your RAG system. So once you define your retriever, generator, and knowledge store, you just assemble it as such. Pretty intuitive, I think. You've got a RAG config here, and then you just query it with a dot query on the RAG system. Um, and then real quick, I wanted to show fine-tuning a RAG system. So you've built your RAG system, you want to fine tune. This is now centralized, right? Um, the way to do that is you need a training data set. So for RAG fine tuning, the training data set is essentially a series of examples containing query response pairs, right? So here's a query, here's a ground truth. That's essentially it. And there are two types of trainers that we support. This is coming from the Radit paper. that showed fine-tuning RAG does have benefits, and they introduced two methods. This is a generator training, so this fine-tunes the generator model. This fine-tunes the generator model by uh, uh, doing instruction fine-tuning with retrieved chunks from the knowledge store. So you're just fine-tuning your generator to the knowledge facts. That's essentially what that's doing. And then you've got an LSR trainer, which is a retriever trainer. I won't go into the details. If you want to get into it, the tutorials are here for like the math, not too heavy, of LSR and RALT if you wanted to get into that. But I did want to show real quick what it looks like. So you build this sort of trainer manager. You say, oh, I want to train the retriever. You pass in these two trainers, sorry. And then you just hit dot train, and it will, under the hood, actually invoke the unsloth or hugging face trainer objects for you. And so that's centralized. And then I mentioned before, like we want to make this like that's the brunt work. Centralized is done, right? What if you want to turn this to federated? Um, so what we try to do is take all of those complexities and put that under the hood, at least for the vanilla version of federated learning, so Fed average. And here you get, if you take your manager, you just do dot get federated task, you get your FL task. And from this abstraction, you can get your Flower server and your Flower client, and then you can use Flower dot start client dot start server, which I know is on the path to deprecation. I think we talked about it, Nick, in favor of the CLI approach, and I definitely want to get more into the CLI approach, but for now, it's using that Dart start client and start server. And then just really quick, what that federated get federated task is actually using, and I will admit, 5 months in, I've been trying to build up the centralized aspects to a certain level. So this federated learning stuff right now is a little bit on the happy path. So it's not super hardened yet, and we're going to be working to make that a lot more robust. But what we've done here essentially is we've introduced this concept of just decorating your training loop and your evaluation function. So if imagine you're a user, or sorry, you're a model builder, and you've built a training loop, a model, and evaluation function for doing a centralized task. What we're saying is with a few lines of code, namely decorating those functions, and you'll see that here. Um, Oh, you won't see that here. You'll see that here, though, I think. Um, if I go to trainers, there you go. So this is a train loop. This is our decorator. And if you decorate that train loop, and if you decorate your evaluation function, then you can build an FL task. Essentially, that's the idea. So much of the work is I've built a centralized training model pipeline. I want to turn this into federated learning, and I don't want to like build abstractions. I don't want to build the Flower client myself. Can this framework take care of that for me? And by doing this decoration and then building an FL task, essentially we are building the FL client, the Flower client under the hood. Really, I know that was super quick. I would definitely, if you are interested, encourage you to read the docs and check out the notebooks that we've prepared. Um, I don't know how yet to prepare a federated learning notebook, and I know Shen mentioned how difficult it is, but I'm going to try, and hopefully in a couple of weeks I'll have one up there. But the notebooks are there. And then just last 2 minutes or so, what I'm going to show you is a quick demo of uh, of federated learning. So here in this demo, what I'll do is,
I was wondering,
sorry,
could you make the screen a little bigger? It's a little
yeah,
small,
is that
perhaps.
okay? Is that better?
Yeah, that's better, I think.
Okay, thank you. Okay, so what we're going to do is we've got a RAG system that is connected to a knowledge store. This knowledge store I have already up and running. And it is a Qgent Docker image that's populated with a very small amount of knowledge facts from a Wikipedia dump in December 2021, I think. And what I'll do is I'll just run the server here. And what we're going to fine tune is the generator using the RALT method. And just a couple notes, it's using Llama 27B because that was the model that Radit used. and we've loaded it up in 4-bit, and we are applying LoRa fine-tuning. So essentially, we're doing federated Q-LoRa fine-tuning using the RALT method here. Um, and here is my client. So this is expecting two clients. It's fed average. I've got a multi GPU setup at home. It's just very modest P100s, very old P100s. And I'm going to set this client to only use device 0. And we could see here, if you kind of zoom out a bit, can I zoom out? There. Uh, what I was trying to show in this right corner, quite quadrant, is if I just zoom out a little bit, you could see the memory usage of the first GPU. I guess it's actually 1 second if I do this. Huh. Oh, oops. There you go. Now you can see the second GPU coming up, right? So they've loaded up on their own separate GPUs, these two RAG system builds, and now they're going to go through, and sorry, I can zoom in now, the federated task. But again, like essentially what the user has essentially done here is they've built the RAG system. They're able to perform this RAG fine-tuning on a centralized task. They did a get federated task. I pulled out the so if I get an FL task here, here's the FL task, right? Get from the train manager, and then I can get the server, FL task server. I can fill in a strategy here. This is just using the default strategy. And then I've got a Flower server. Similarly, with my FL task, again, get federated task from that centralized train manager, supply in my params, I've got a Flower client, right? And then I just use the start server, start client. Um, Hopefully that feels like it's a little bit easier to go from centralized uh, to federated. And as I was speaking, the demo finished successfully. That was just one round on 3 training examples. But again, that's essentially the path that we're trying to take. Super easy transformation from centralized to federated. And I know I probably went over time, so I apologize for taking a lot of time.
No problem. Thank you for both having, quite a good articulation about, what's behind your thinking in this framework and also putting in a demo at the end and showing docs in the middle. It was really cool. We are a little bit short of time, but if somebody out there wants to ask a quick question, raise your hand on the Zoom or I'll quickly check on our Slack or the YouTube. Um, I do see there is a question, but I wonder. I have a feeling this must be for Chongshen's talk. It says, one small question, which are some key characteristics of the connection between clients and servers? Or maybe it applies to this talk. Um,
Sorry, what was the question again?
yeah,
Did
the question comes from Federico. He writes, one small question, which are some key characteristics of the connection between clients and servers. I
I
guess,
wonder if, yeah,
yeah,
what do
I
you
guess
think?
as it applies to, as it applies to your library, I suppose the connections, they're just going through the regular flower connections, I suppose, so that'd be gRPC and that sort of thing. So I guess that's the answer to the question, I think. What are the key characteristics of the connection between clients and servers? Um, yeah, gRPC based.
Mhm.
Um, yeah, and I guess the default would be a central aggregation server and some clients out there. Yeah, I think that answers that.
Yeah, I think so
Um,
too.
I guess one quick question is what is what do you feel is the next big thing that will unlock something for this library? So I think you even mentioned a few things that are coming up next, and you mentioned also this, I guess this bigger mission of keeping it simple. But I was curious about what would be, yeah, what's something you're really excited about that sort of within arm's reach that'll be a big unlock, but maybe you haven't mentioned it yet.
Yeah, that's a good question. I don't know if this is within arm's reach, but it's definitely something that is very important, right? Like, I think we've built up the framework now to a point where you can use a bunch of tools, and there's enough here to facilitate RAG fine tuning and advanced methods, in fact. And it's now a matter of just dog fooding it and showing the benefits of fine tuning your RAG systems. Centralized as well as in federated settings. And I think that would be the biggest unlock right now, in my view. And then I think my hope is that as you show the benefit of RAG fine tuning for both practitioners and researchers, that then you get higher user adoption. And then from that, it sort of informs the next things that we should be focusing our efforts on, if that makes sense. But the other thing I wanted to say was, I think in your Flower AI research page, there was something about efficient message passing, I think, of LLMs that
Yeah.
or was it depth or something like that? Yes, I think that is something that needs to be looked at a bit more because obviously in my demo we were doing QLoRa. I think you want to get as much as possible closer to full fidelity to get increased performance in your fine tuning. And so I think efficient message passing or creative message passing to facilitate full fidelity fine tuning would be great. But it looks like you guys have done that stuff too, so that's something that I just need to catch up on.
Oh no, to be honest, I think there's still tons to be done. I think we've offered, and in the depth work you mentioned, we offered some alternative ways of using embeddings that are fairly particular and interesting. But there's ideas that only really surface when you look at a federated system, I think, and then you can kind of see how they get used in other ones. But I agree because I think also all the PEFT work that's been done is really great. It's a big enabler, but it was also coming at things from a very centralized mindset. So I think there's tons of interesting other ideas that can benefit actually centralized once you start thinking in these terms, how you can balance different types of comms and compute overheads. Yeah, perfect. Cool. Well, I think we should move on. Thank you so much. That was really interesting, and I can't wait to see what happens with FedRAG next. It's really a great piece of the ecosystem, I think.
Thank you so much, Nick. Thank you.
Cool, cool. Um, Let me share my screen, and we can dive into our final invited talk. And so we're about to have a great talk here from Adapata. She is at, I hope I'm saying this right, but I believe it's appropriate to say the Heilbronn University. But maybe you can correct me if I've kind of mislabeled it. But I did.
It's called Heilbronn. So with the
Oh, I see.
it's EI, it's A usually pronounced. So it's Heilbronn.
Heilbronn. Okay, got you. Okay, cool. Thank you for that. Sorry about the pronunciation. But yes, she is going to bring some, highlight some of the work she's been doing in, I think, an important area. It's broadly sits within this interesting questions related to decentralized trust, which is, an important set of questions, I think, particularly when we build systems that are very sensitive, that we really have to trust and so forth. So I'm fascinated to see what she has to tell us. Over to Adapata. Thank you for joining us.
Thank you for having me. I am sorry. Can you see my screen now? Hello?
Yeah, looks great.
Okay, great. So I am going to talk about decentralized trust in AI model sharing. It's more about how we collaboratively train model or use model or share model from one research lab to another research lab or for global collaboration. It's basically, if you look into, I'll just start with my introduction. So I am Arpita Sarkar. I'm recently have turned to a founder of Orchid.dev. I'll talk about it later. But I'm a research assistant and as a system architect at Institute of Cyber Physical System at Hochschule Heilbronn, where we do embedded system researches. And I have worked on two European Union funded projects. where I have developed a messenger, one of the messenger, and a research collaboration tool for universities connecting in the European Union. So while working for this project as system architect and also being a PhD candidate there, we came up with a very big problem because it's when you're training data models, it includes data, and when there is data privacy. So, federated learning is now a hope to the data privacy. It solves the privacy issue, but there is still more issue like what happens after training. There is two phase when we are training a model and then collaborating, aggregating the collaboration. So, federated learning is solving the privacy, but still there is a lot of need for more research in trust, provenance, and transparency that needs to be maintained while collaborating between research labs or institutes, because if you see in modern world, all the big llms, the state of art llms, are owned by big companies because of the central aggregation. We don't know where they what data they are using, how they are training, because it's done under one in the siloed way for big companies. This is one of the reason Europe also lacks one combined LLM, I would say, but that was a part of research when we started the research. Then it went on to a solution. So I'm sharing today a part of the research, but there is a big solution from research collaboration to some of the tools for helping in the collaboration. So today I'm going to focus on the challenges that we still face after having federated learning. That is verifiability, like whose contribution and the logs. Still, some of the solution solves these logs, but these logs are not immutable. And then there is always a central aggregation. Uh, if we want to make a democratic AI, that AI should not be siloed and taken decision under one roof. The decision should be democratic by different peers. And then we also believe like training in a federated way is excellent for privacy solving, but also we need more innovation when we need to aggregate not only heterogeneous data sets but also heterogeneous models. Then the trust and transparency, it's like the contribution is lost because of this continuous process of updating a model, forking a model, and then as with we are fine tuning different versions of llms, so this becomes even more needed. So, what is Trust Chain AI? This is a part of our contribution where we start Trust Chain AI, a decentralized framework. So, what is the innovation? The innovation lies in like MLOps, Web3, and decentralized orchestration. So how it happens is when in a decentralized manner, in a federated way, when institution are training different models. For example, one institution is fine tuning but another institution is fine tuning GPT, and for example another institution fine tuning a llama, or different, that might be on same task or might not be on same task but could be on similar field, for example medical technology. So when they are training the collaboration happens when you train different models in your local institution, and you only share the weights, not the data set, and the playground. And then there is a playground where users in the peers get notification in a matrix based server, all the peers, and they can vote play by real users, the makers of the group, and they vote for the models. With the models which passes the vote gets accepted, and these are matched with an iota tangle hash, that is a blockchain network, and then we get the knowledge distillation and togetherly a global shared model. Let me break down the parts a little bit. What is the Matrix messaging server? So some of you might already know Matrix is a communication protocol. It is a decentralized communication protocol, and right now one of the most secure peer-to-peer communication protocol. It's believed by European Union Space Agency, NASA, and Gematics, German government medical system. Why Matrix is unique? What Matrix does is even when we are sharing the model, it takes the model as a message, it encrypts in one layer, and then the server you are sending, like your source, your resource institute, and the message together, it gets second encryption. So Matrix is right now giving us the support for double encryption of the weights, and also from where your server is coming. And all this information gets logged via iota tangle. Tangle is a blockchain like a system made in Germany, founded in Germany, now in UK. It's it's a decentralized way of storing the hashes, but unlike blockchain where it's bottleneck, and the information, it gets a lot of time, and you see sometimes like traditional blockchains like Ethereum and um, Ethereum, that gets very high gas fees because of this bottleneck situation. But Tangles, it can take one at a time, several nodes acceptance, and it's free for now, and also, and this is feeless. We can use it in the research project. Then in the tangle, the hash gets stored, and when you send it to the Matrix communication network, what Matrix does, it sends this information, like the metadata of your contribution. For example, what model you have trained on, what kind of data sets you have used, the link for your playground where you have deployed, and this metadata is sent to all the peers in the network. The peers in the network test the models, and if they think the model is good enough, they give vote. The voting period ends for 5 to 7 days, and when you reach up to 70% of the votes, this model gets to a global aggregation platform where the knowledge of task specific from different institutes gets distilled to a global model. Now, some of the innovations that we'd like to mention. Number one is verifiable provenance of ownership. So when someone is putting the model in the server, you have a metadata. This metadata is locked with the hash, and this hash is stored in iota tangle, and with that hash, your contribution is logged throughout the Matrix server, the voting. Then again, if someone wants to fork the model for a better use case, all of this gets stored with that hash. And as we know, like the recent the blockchain system, with that hash we can always prove if the contribution was made by this owner or not. That gives us another authentication of when, for example, there is a problem with Git when we are updating our contribution. If someone downloads the contribution and then try to upload the same model, they can do it, but unfortunately here they cannot, because when you are tied to a hash, you always get the notification of you have forked or updated the base model and who was the creator of the base model. Then the democratic community driven validation. So when you are uploading the new model, as I mentioned, you are uploading the information of metadata of what is the base model, what you have fine tuned it for, what kind of data, and a link to the playground where people can test, like people in the server can test your model. So this notification is sent to Matrix, all the community users. The community users access the model, they submit their vote, and the votes together tallies the consensus if the model is accepted or the model is rejected. And by this way, we are getting democratic community driven validation, not a central validation. Then the third part is the adaptive aggregation. Okay, so knowledge distillation is commonly used for heterogeneous data sets, but we have tried to use knowledge distillation in heterogeneous models as well. For example, we have used BioBard for question answer, Llama for question answer, and Bard for NER, like different kind of tasks, not only question answer tasks, different kind of tasks, not only one model like Llama and Bard GPT, different models. And with that, what we did is, in the first version, when you have the same base model, we are distilling the knowledges with soft labels, where the student models learn their from the teacher model, like the base model. The student model learns the task in with the knowledge of all the probabilities. Then the student models who gets approved, who are approved by the consensus of the whole network, those models acts as teacher model, and then togetherly collaboratively teaches one central global student model. So at the end, the global student model gets more powerful and multitasker. But I would still like to mention that for each task, a specific task, the first the student model that was created from our, like, the peers who are contributing in the network is of course way more accurate, but our global model is a multitasker. The experimental setup, for the experiment, we have tied up approach of a model aggregation. We have tried to look into that a little bit more. But for NER teacher model, we have trained BioBart. For that student model was used to train all the global model. For question answering, we have trained Llama and BioGPT. And for the ICD, we have trained BioBart, because BART is outperform in classification. So the data sets we have used for NER code 19. For question answering, we have used BioASQ. For ICD, we have used Mimic 3 and Mimic 4 clinical data sets, but real data sets to validate. Then we tried to validate it for like one specific task. For example, the name entity recognition, NER task for the distill model. So the global model have so in like the knowledge distillation way, if you see, the global model have performed almost similar to the first teacher model, who were trained on the main model, and which was fine tuned on the main model. So it's almost performing that, which validates our ties that decentralized voting and metrics voting when needed, because when we first started the distillation with all the tasks, it didn't perform that well. While the aggregated global model shows decent accuracy, it reduced like the F1 score a little bit, and that means like forking or like having different opinion and having like more kind of task knowledge aggregation have improved its own task in the name entity recognition as well. So we also studied it with all the models. For example, our question answering model of Llama and GPTs, and also the global question answering model and the knowledge distilled question answering model with the normal knowledge distillation process. So what we found out is BioGPT performed best, as I told you, because it's the main model which was fine-tuned, so it will perform best. Knowledge distillation preserves high similarity in Llama, and validation architecture effectively fuses diverse teacher signals. That means the model is performing in all the tasks and question answers. The key insight, the heat map compares, like we tried to compare, because we cannot do federated average with all the models, but with the BERT and GPTs, we tried to make a combination of federated average, and we tried to compare that. So in that case, the heat map shows the distillation of federated average was better in that task, but superior when the knowledge distillation approach comes. So it becomes superior with the loss functionality. So that means when for example, what we tried to do here with the LLM is we used medical data set. How we trained it as a question answer on medical data set, then we trained on different task specific. For example, the name and entity recognition with medical data set as well. So the thing is, the question answering model performs better when it has more specific knowledge fed into it. For example, like distilled with the knowledge of recognizing the entity with the name of medical data. So the question answering model is performing better. And we have also seen some like enhancement in fairness and robustness. This was due to two things. One part was definitely because of the knowledge distillation method we have used to have a global student model. And also another part was because we made a simulation of our environment, and we tried to fork a question answering model with more knowledge of name entity recognition to see how it answers the medical question now. So in that case, that forking was also proved to enhance this result. And the impact, I would say it has shown quite good impact. The knowledge is delivered and the model is getting multitasking. Of course, it's losing a little bit of its accuracy from the base model when you're distilling the knowledge and making it multitasker. But also our method has proven it has enhanced in fairness and robustness. So, final thought is trust in AI enables privacy preserving decentralized LLM training across institutions using secure communication, consciousness voting, and knowledge distillation. This process is fully automated, like when you push the model from the server to our server, the model, the metadata goes to all the peers from the metrics server is triggered, and all of the system, the count of vote, the hashing, and then checking the hashing before aggregating it to a global model. All this process is fully automated, and this would we are hoping this would open an AI collaboration to big vision, like having big LLMs of our own language or multi-language or multitasking. So we are turning our research into reality. Currently, I have submitted my PhD thesis last month and now waiting for a defense debt. I have also started founding this project into a bigger project like Fork It. That's a decentralized platform for secure collaboration. And we are now testing it with ICPS and Lab 3. I would love to hear questions from you, and would also like if you would like to know more, you can join me in my LinkedIn. We can have a talk.
Great. Thank you so much. Probably a bit over time, but as usual, if anyone has some questions, just raise your hand. I'll check out also the YouTube and the Slack. I don't see. Let's see, looking under questions and under Fly Monthly on the Slack here. I see. Oh, there's one question that I think is quite specific. They're asking, you mentioned similarity with the radar plot. Is that calculated assuming blue as the metric?
Yes.
Oh,
The
that's
blue.
okay. Okay, similarity based on blue. Okay, that's an easy one. Makes sense. Well, I think yeah, maybe I'll ask a question too. And there was I was with Fork I think it's called
For me,
forkit.dev.
yes.
Yeah. So with this new initiative, are there any particular like industries or scenarios you're trying to target? Or
Mostly the research collaboration part, because as I mentioned, I have started working on it from a research collaboration tool like a messenger, which was also based with the metric collaboration. So when researchers are collaborating, I have deeply worked with the European collaboration network. So the first thing comes with privacy security. the
Mhm.
the thing is, we started with an NDA, blockchain based NDAs, like document sending and receiving it back. Then we came up with a point, like when you are we introduce in that okay, I'll just give you an overview of our platform, where it's a metric based messenger, where each of you, like for example, you can have a bot, Gemini Nano kind of bot on your device, that runs on your device. You can explain it about your life. It makes a profile on your device, and this profile never leaves the device. It's always on your device. And what metrics can do is it can send all the messages from peer to peer at a same time. What we are doing is we created a bot inside metrics network. So whenever someone wants a collaboration, for example, I want to collaborate on fine tuning a llama for maybe venture capital specialist dataset. So
Sure.
someone who's working on a venture capital, someone who's working on llama data sets, only those people like the whose profile have this information gets the notification, and then they collaborate. Now the next part comes in here. When they wants to collaborate, how to collaborate, like having all the contribution logged in, for example, who have contributed how. Even it's not only in real contribution in the sense of only the coding, but also contribution of ideas and everything. So all these are logged in the matrix dataset with your hash. So when you start developing a code, so everything, for example, someone wanted to fork and say start a topic like we need more data set to fine tune this, or I think the way we are fine tuning is not good, we need to change the direction. So all
Mm.
these forks are also attached to the hash. So you have a whole log of whose contribution is how much you have contributed, and then you can always find out after which contribution there was a fault. So this is kind of an ecosystem. We are trying to make a B2B program out of it, like product out of it. But on the other hand, we also provide like looking into an open source network where single people, like anyone who is a single researcher who do not have maybe a specific data set they are working on, they want to share and still collaborate together, maybe get some vision. So this is open source for everyone. That's like the two aspects we are trying to build community together.
That's excellent. I think a lot of researchers would love to share more resources to kind of do more scalable work, given the direction of a lot of the EML themes are in that way. Maybe one final question. Andre has patiently been waiting here with a question.
Yeah, just a quick one. I hope I pronounced your name correctly there. Sorry if I didn't. Um, so with the model, I think verification piece, is it like a human at the end of the day that's accepting, I guess, based upon the metadata that they see?
Yes, yes. They not only
Okay.
based upon the metadata. It's like
Okay.
with the metadata, you are giving a link of your collab or somewhere you have deployed it to test the model. So
Okay, you could test
meaning
the
for the
model.
7 days, they can test the model, all of them. Like we are storing it in our IPFS, and every like the peers all can real person can chat with the model, because right now we have only LLM based. So can chat with the model, get the feedback, and then give votes if it's correct or not. So it's like
Okay.
the whole system is not sharing any data sets. It's compliance with GDPR and all.
Okay. Got it. And I've got one last follow up to that. Actually, I just that one that response just spurred a follow up, which is there any concern about distilling in those? Like, I think effectively you've built a clean room to test these models, right?
Hmm.
And is there any concern here that you can take something away from these clean rooms without any without accepting the model, or do you know what I mean? Like, because like the way I see it is like, and this sort of segues into my next question is like, are you thinking of like building an economy of like a market, a model sharing or even data sharing? So like, here I am with the data or model. I'm like, it works. You could test it for yourself. And if you accept it, I get a certain token amount back, right? Like that's essentially what I think building on the Web3 allows, right? So,
Yeah, actually, basically, I'm using IOTA. So
okay.
I have talked to IOTA, like the founder of IOTA. We had a few conversations. I'm trying to get some funding from there. If it is happening, then yes, that's a vision. But
Mhm.
I would like to still say it's not like monetizing or tokenizing your data sets. It's more on like the models, because the first thing is we are not sharing data, we are only sharing weights, and it's
Mhm.
only for 7 days to the peers only who can test the models and vote. So no data is being shared, like even raw or weights. And on top of weights, see, the distillation process is also a teacher student kind of one that mimics the teacher. So we are trying like to give all the precautions of not even reverse engineering and getting the data sets.
Cool. Cool. Thank you for that. It makes a ton of sense and seems very interesting.
Yeah, I concur. Seems really pretty compelling. It's certainly needed. It's a tough problem. I think it's
Mhm.
probably the most open problem that we had to look at in this event this monthly. But yeah, thank you for the talk. I am going to then wrap up Flower Monthly for the month of June. I want to thank all our speakers. We had three fantastic talks today. I really like the sort of diversity of ideas. And I think we're all pushing in the right direction in various vectors towards taking this decentralized, this federated methods mainstream. So wonderful to see. We will be back July 2nd. As usual, that's the first Wednesday of the month. We have this 1600 UTC that is fairly compatible with most locations on the planet. Um, if you want to find Flower Monthly recordings, you can go to the part of our flower.ai page. If you want to participate, maybe propose talks, suggestions for Flower Monthly, we've got a particular channel in our Slack for this. Join our Slack if you haven't. And this event and all the other events that relate to Flower on a Flower calendar, you can check out that nice and easy to type in URL or go to our page and just click a button. But again, thank you for joining us. Thank you, speakers. Thank you, folks out there. Take care, and I'll see you next time. Take care. Bye-bye.
Thanks for having us. See ya.
Bye.
Bye.